This is lesson 4 of the advanced material, evaluating square roots and cube roots. A square root is the inverse of the exponent 2. If I take the number 8 and I put it to the exponent of 2, or 8 squared, I am saying 8 times 8, which is 64. If I take the square root of 64, I get 8. I started with 8 and I ended with 8 because the two operations are inverses of each other. The same holds true about cube roots, except cube roots are the inverse of the exponent 3. 2 to the third power is 8 because 2 times 2 times 2 is 8. But if I take the cubed root of 8, I will end up with 2. I started with 2, I ended with 2, because the exponent 3, or cubing a number, is the inverse of the cube root. You are also free to use the perfect squares and perfect cube charts that were attached for the interactive notebook, or you can use a calculator for this. The Desmos calculator that is hooked to Canvas is an excellent tool. You've got your key concept on your next slide. The cube root of a number is a number whose cube is equal to that number. Cubing a number and taking the cube root of a number are inverse operations. Just like squaring a number and taking the square root of the number are inverse operations. These operations simply undo each other. Let's go to the back of the first page of your notes if you've printed them out. A cube-shaped art sculpture has a volume of 64 cubic feet. What is the length of each edge of the cube? If we're talking about the volume of a cube is found by length times width times height. But in a cube, these three edges are all the same. So instead of saying length times width times height, or edge times edge times edge, we can say edge to the third power. And in our problem, we know the volume is 64. So I'm going to replace the V with 64. 64 is equal to the edge to the third power. I'm now going to solve this equation. In order to solve this equation, I need to get rid of the exponent 3. I'm going to use its inverse, the cube root. So I'm going to find the cube root of both sides. The cube root of 64 is equal to the cube root of e to the third power. On the right side, the cube root and the exponent of 3 undo each other. So we're left with e. And the cube root of 64, if we put it in our calculator, is 4. So the box and the edge of this cube is 4 feet. The question underneath it, what is the cube root of 64? The cube root of 64 equals 4. Why? Because 4 times 4 times 4, or 4 to the third power, is equal to 64. We're going to evaluate these. The cube root of 64, again, that answer is 4. The square root of 25, we're looking for a number times itself to be 25, and that is 5. The cube root of 2,744, you can look on your chart, you can put it in your calculator, but the answer for that is 14. And the square root of 81 is 9, because 9 times 9 is 81. I want us to stop here for a minute and look at a couple things. Let's start with the cube root of 64. 64 is a special number. 64 is a perfect cube, and it is a perfect square. That means I can take the square root of 64 and get a whole number, and that is 8. So 64 is both a perfect square and a perfect cube. But even more than this, I want us to look at the two square root problems. On these square root problems, we find that the square root of 25 is 5 because 5 times 5 is 25. The square root of 81 is 9 because 9 times 9 is 81. The square root of 64 is 8 because 8 times 8 is 64. But is that the only valid answer? It's not. I want you to think of the left side of a number line where the negatives are. Negative 5 times negative 5 is 25. That is another answer to my problem. So I can say that the square root of 25 is equal to both positive and negative 25. The same for 81. Negative 9 times negative 9 is 81. So again, we can say positive and negative 9 is the answer. Along with our 64 over here. 8 is not its only answer because negative 8 times negative 8 is positive 64. So positive and negative 8 is a valid answer as well. This does not hold true for cube roots though. And the reason is we end up with 3 negatives. If I try it on 2,744, I have negative 14 times negative 14 times negative 14. Well, 2 negatives will make a positive. 3 negatives in a multiplication problem will be a negative. So cube roots have one answer. Square roots can have 2 answers. Emily wants to buy a tablecloth to cover a square table. She knows the tablecloth has an area of 9 square feet. What are the minimum dimensions of the tablecloth Emily needs? We know the area of 9 square feet belong to a square table. To find the area of a square, we're going to do side to the second power. Side times side, they're going to be the same number. The area is 9. 9 is side squared. To get rid of this, we want to find the square root to get rid of that exponent of 2. So we see that the side is 3. But the question asked for the dimensions. When we're asked for dimensions, we need to be specific to length and width. So we would say 3 feet by 3 feet. This is the minimum dimensions of the tablecloth Emily needs. A cube has a volume of 8 cubic inches. What is the length of each edge? Volume of a cube is edge to the third power, length times width times height. The volume is 8 cubic inches, and that is equal to the edge to the third power. Use the inverse of the exponent 3. That is the cube root. So we are going to find the cube root of each side to get rid of my exponent 3. That leaves us with the edge is equal to the cube root of 8. The cube root of 8 is 2. So my answer is 2 inches. This is on page 2, the second sheet. Well, I guess it would be page 3, but the second sheet of your notes. Mrs. Drew wants to build a square sandbox with an area of 121 square feet. What is the total length of wood Mrs. Drew needs to make the sides of the sandbox? Let's think about what she's making. She's building a square. It will have an area of 121 square feet. How do we find the area of a square? Area is equal to the side squared. The area needed is 121. That is equal to the side squared. We need to undo the exponent of 2. In order to do that, we need the square root. So we will find the square root of both, and we find out that the side is equal to 11. But let's think about the question. One side is 11. Is she only going to make one side of the sandbox? I don't think so. The sand would fall out. She's going to need to create all 4 sides of the square. So Mrs. Drew is going to need 4 sides of 11, or 44 feet of wood. Sometimes it's best to go back and check and make sure our answer makes sense to the problem. In this case, the 11 wouldn't have worked. Okay, one more question from this lesson, and I'm going to let you practice some on your own. Talia is packing a moving box. She has a square framed poster with an area of 9 square feet. I'm going to stop right there, and we are going to draw this. She has a square poster with an area of 9 square feet. The cube-shaped box has a volume of 30 cubic feet. Well, now she's got a box. And the box has a volume of 30. Will the poster lie flat in the box? In order to compare these, since we're comparing a square to a cube, we need to know how big the edges and sides of these two shapes are. So let's undo the area and the volume. Area is side squared. We have an area of 9, so let's find the square root to find the side length. And we find out that the sides are 3 feet. That's her poster. But then we also have to think about the box she's using. We were given volume, and the volume is the edge to the 3rd power. The volume is 30. How will we use that to find the edge if we know it takes the power of 3? We'll find the cube root. When we do that, we actually find a decimal number. We get an irrational number. So let's estimate this just a little bit. And the cube root of 30 is about 3.1. So the edge of this box is about 3.1 feet. Do you think a 3-foot poster can fit in an area that is 3.1 feet? I do too. So yes, she has enough room. Now I want you to go and try the other questions for this lesson. If you have any questions, I want you to contact me. You can inbox me on Canvas, or you can meet me in our virtual classroom between 2:15 and 3:15. I can't meet on Tuesdays, but I'll be there all the other 4 days. All you have to do is click the coffee cup. I will also upload the answers, but as I tell the kids here in class, just copying the answers that are given to you is not going to help you. You need to be trying this on your own. Once you've tried it on your own, then compare your work and your answers. I look forward to talking to you soon. Check in with me every now and then and let me know that everything is going well. I want everybody in here to be able to do their best, and I can't help you if you do not let me know what you need. I'll talk to you soon. Bye.